So as I mentioned, the supply chains today are becoming very complex. If you talk about something like a mobile phone, it's made out of a lot of components. And to manufacture a mobile phone, you need different suppliers who all produce different parts that are assembled. A lot of that production happens in Asia and Southeast Asia. Some of it happens in Europe, some of that happens in the US. So to build a phone, you have to make sure that all these parts, if you're saying, well, this final assembly is happening, you need to make sure that all of them arrive at the right time. There's no point in getting all the phone chips if you don't have the touchscreen controller, for example. What will happen is you will end up with a large stock of components that take up space that you can't use. So these supply chains, as we mentioned in the beginning, are more like networks, and networks that span the globe. And to manage them and keep them cost efficient, you have to think about some cost elements. So the key thing here is to reduce the inventory levels. You want the products and the components to be there the moment you need them, not too late, obviously, because then your production will hold, but also not too soon, because they will take up space. They might become obsolete. You need extra storage space, extra handling costs. So that part we call just-in-time production. Your supply chain, your production is stable, but you reduce the inventory levels. So you will only get the inventory right the moment you need it. So that reduces the stock, and that means you have to put less things on the shelf, you have to manage your warehouse, you have less management in your warehouses. But most of all, it reduces the chance of things becoming obsolete. The longer things stay in a warehouse on the shelf, the longer the chances are there will be a new product on the market, and which reduces the value of the components you have. Think about if you're producing a phone and you're ordering a processor that you're going to put in the phone. Suppose you order 100,000 of these processors, but you only produce a couple of thousand, but you say, well, let's keep the rest in stock. But then a few months later, while you still have this stock, a new model comes on the market that is faster, that has more processing power, and that's better that the consumer wants in their phones. Meanwhile, you still have these old processors, so now you have to decide whether you're going to discard that old processors, or you're going to reduce the value of your phones and you're going to use them to manufacture cheaper phones. But anyway, the value of that stock you were holding has changed. So the more stock you have, the more inventory you have, the higher the chances are that something will happen that reduces the value, in addition to having more cost from managing it. One way to do this just-in-time production is what they call vendor-managed inventory. So the vendor is essentially the supplier. And what companies do is they give suppliers access to their inventory systems. And the suppliers, the vendors, will decide will ensure there is enough supply. Think, for example, the Albert Heijn or a supermarket near you that has a warehouse system that knows exactly how many products are in order, how many being sold. Now, rather than them telling every time to different vendors what they need, they have given vendors access to their systems, so that Coca-Cola, for example, can see how much stock Albert Heijn has and can automatically decide to produce more and start delivering it. So rather than the company that needs the products are ordering, they do the other way. They make an agreement that the vendor is responsible for ensuring there is a minimum stock of this amount, and they will give access to their inventory systems so that the supplier can plan when and how much should be delivered. So that is called vendor managed inventory. You transfer the management of your supply to a vendor. And the advantage of that is that, of course, you have less handling. You can reduce the cost of procuring it because you don't have to every time negotiate. And also you can rely on other people to plan the production for you, to be responsible for, making sure there is enough production to supply and to replenish your inventory levels. Because Coca-Cola is the manufacturing, they have a better understanding of when and how they should produce. And that vendor managed inventory is one example to reduce that bullwhip effect. Because now that original manufacturer or producer has access to information directly from their client or from the consumers. So that reduces the ripple effects. And so that's one way to manage that bullwhip effect that we talked about earlier. The other way to do it is to coordinate the supply chain. So you will step out actually from your role as one chain in the supply chain, one element in the supply chain, but you will sort of safeguard the whole supply chain, and you will act as a management agency that has an overview of the whole supply chain. And in all of that, technology and information technology is an important enabler, because you will notice that all these things drive or are built on information. Knowing what the inventory is, knowing if there's disruptions, knowing what the consumer demand is, knowing what the production is. So information is key, and information technology, especially if you talk about global supply chains. Remember what we said in chapter 5 about connecting remotely and asynchronous. Information technology enables people to exchange that information across the globe, across different time zones. So there's a lot of different systems that are being used for this. There is demand planning and forecasting. There is safety stock planning, distribution planning, all these different elements that are part of managing a supply chain. So these are all the kinds of choices you have to make. If you talk about safety stock, how much are you going to keep in your inventory as a buffer? If you talk about materials management, how much do you need to actually do the production? How much do you need? Where are you buying it from? Transportation execution. So how do you get the logistics working? How many trucks do you need to move? Do you need something special? Do you need customs? Do you need planes? Are you working with dangerous goods? And so on. And especially the last one, supply chain analytics, is key in monitoring if that supply chain is working. And you can imagine that, as you saw in that FedEx video, the bigger the supply chain comes, that becomes a whole important field in itself. So as you heard, there are some trade-offs that you have to make when you're making this supply chain management strategy. So considering all these different elements you saw on the table, there are some trade-offs. Right? Minimizing costs, for example, by reducing inventory levels, also increases the risk that if you don't have an inventory, you don't have a buffer, and for whatever reason, whether it's disruption, miscommunication, technological failure, you can run out of stock and then production will halt. You can also run the risk of decreased customer service. For example, if products are not available, or you don't have the logistics in order to make sure the products get delivered to the customer. So the more efficient your supply chain becomes, the higher the fragility might be, because you have less inventory. But also you might start reducing customer service because you have less to offer, or it takes longer to deliver to the customer. Some companies actually use that last part as a strategy. If you have a highly popular product, reducing the availability actually is part of the marketing strategy, not supply chain strategy, but marketing strategy. Think about Apple, where people are waiting in line to get the new iPhone. So efficiency and effectiveness, and then if you talk about supply chain effectiveness, that's different. So efficiency is really about reducing the cost and then making trade-offs. Effectiveness is, how do I make sure that I do the right things while keeping in mind that I want to reduce costs. So efficiency is really internally looking at, how can I manage this efficiently by reducing costs. Effectiveness is taking outside is, am I doing the right thing, and how can I doing this right thing with the resources I have the best way. So often people focus on efficiency, but it's better to focus on effectiveness, depending on what your strategy is. So if your strategy is indeed like an iPhone that's based on the marketing strategy, you might get away with, not having stock everywhere. People are willing to wait for it. But if your business strategy is a high volume and a low price, you want to make sure that people can get access to your product, because otherwise they might turn to a competitor if you're in a highly competitive market. So efficiency is really the internal one. Effectiveness is where you start looking at your competitive advantage, your strategy. What is your e-commerce strategy? Then design your supply chain around that. So when you're developing the strategy, these are constant decisions you have to make. Are you focusing on the efficiency, just reducing cost, or on the effectiveness? And from that, you can start looking at different elements such as procurement. Do we need more inventory? Do we need to get multiple suppliers if we want to be less dependent on one? Are there more? Versus, if you do efficiency, you would focus on a single supplier. Same for production. If you're effective, you can change production, you can increase capacity, you can reduce capacity, but efficiency might just reduce on, removing excess capacity. In effectiveness, depending on your strategy, you might say, I need more capacity to scale up. And the same goes for transportation. You say, well, if it's part of our strategy to have our products available to the customer, any customer in the world or in this country should have access to our product within a day, you probably need more warehouses. But if you focus purely on the efficiency, you would reduce the number of warehouses and accept longer delivery times. So to do these things, all these elements in your supply chain, they have to work together. You need to have agreements with the supplier, you need to have a production, a distribution, logistics plan, and you need to know what the customer wants. So all of these elements that make a supply chain work have to exchange information with each other and have to understand the relationship. So with a supplier, you have to understand how much can the supplier provide you, how regularly, what volume. For production, how much can I produce? What is my maximum capacity? What is the minimum capacity? Distribution, how much shipping can I do? How long will it take me to deliver things? And eventually, what does the customer need and want? And we'll get back to that, what the customer wants, in the next chapter. So all of these elements go into the planning and they're all influencing each other. So then the planning process, you have a demand and a forecast. You, for example, build on historical data or on market analysis. You have an understanding of what the demand might be. From that demand, you can start thinking about how do I distribute, how do I get the products to that demand. So how many products do I need to provide and where do they need to go? So you can do transportation planning. Now I know how many products I need to deliver. I know how often I need to ship things. You can start thinking about production. Do I need to produce a lot in a single batch, or is it more steady stream of products that I need to produce? And from that production schedule, you can start thinking about your inventory. How much stock do I need? How much do I need to procure? How regularly do I do it in batches, large batches, small batches, and so on. And from that planning process, you go to execution. So you focus on a flow of products, information, and finances. So if you look at the production flow, so the upper layer here, the upper layer here, it's products. You take raw materials, you put them in production, you're going to deliver these products, and the customer will receive the product. Information goes the other way. It goes one way by saying, well, how much does the supplier deliver? How much are we producing? How much are we distributing? What is the capacity? What does the customer get delivered? But the other way around, as I said, you can also go from understanding what the demand might be to your distribution plan, to your production plan, and then to procurement and your suppliers. So in information, it flows, the production flows one way, information flows both ways. And then, of course, the financial flow goes the other way. Customer buys something, they pay you, they pay the distribution, you pay the distribution, that from that finances you pay your production. And then production, of course, you need to purchase elements from the raw materials from the supplier. So finances really flow from the consumption back to the original supplier. Products flow from the supplier to the consumption, and information actually flows in between these two lines. So this product flow is one way. So it's movement from goods from the supplier to production, distribution, and then to the consumer. And as you saw in the FedEx video, an important part of that production flow and distribution flow is tracking. And there's different ways. Barcode is a commonly used example, and now RFID, radio frequent identifier technologies, so chips that broadcast a signal, are also used to, within the supply chain, track products at different stages. The information flow, that's facilitated by different technologies. So information flows, as we said, through ways to that supply chain. And in each step, different systems are being used. A production system, enterprise resource planning, marketing, customer portals, websites, e-commerce. They're all different but connected systems. So what is underneath to make sure that that information can be exchanged is technologies such as data standards or data formats like XML, Extensible Markup Language. Those are data formats that most systems can understand, regardless of what the system does. So data from a marketing system with customer information or forecast can be understood by a production system using those kinds of formats. We'll come back to that in a minute. And then financial flows are really the financial assets, invoices being sent, consignments, so people are signing off on the goods sent and the goods received, and who is the ownership. And that's often, again, linked to electronic banking and financial institutions, also enabled by the information. We already talked a little bit about that information, and that is a key enabler between the production and financial flows, the product delivery, and the payments, but also in terms of planning and strategy. So what does information and the analytics play in here? Well, first of all, it's product tracking. It's knowing where your products, your supplies, things are in the supply chain, if you have enough of them, where they are, if they're available, quality, and so on. It can also help you anticipate. For example, if there is forecasted bad weather, if there is socioeconomic effects. So tracking and analyzing your supply chain will help you understand what the effects might be on your supply chain. If I know how much dependent I am on one airport or supplier, I can use those analytics, those insights, to understand what the impact of a typhoon might be on my supply chain. So you can use it as forecasting and anticipation, and you can take measures by increasing your inventory levels or finding an alternate supplier. And then, of course, during the execution of a supply chain, during your production, your delivery, those systems can help you monitor the supply chain. How well are you performing? Is there downtime? Are there any problems along the supply chain? Are there hiccups? And often systems can even visualize, in inventory levels where there is a problem or a backstop. I already talked a little bit about this technology called the Extensible Markup Language. And there's many other formats. JSON is another one. CSV files are also commonly used. So those are files, data, stored in a structured manner. And you can actually differentiate between two things. One is the syntax, and the other is the semantics. So the syntax says how are you going to store the data. For example, the dates are stored with year, month, day. That's a syntactical choice. Or you can say we'll store the zip code with 4 numbers, 2 letters. That's the syntax of a zip code. So you can agree within systems to say, well, this is how we're going to store the data, and you can export that data in, using the syntax in certain formats, like in Excel or in XML. And this is one example that's commonly used. And that way you can take data from one system and use it in another. through, and that could be manual or could be automatic, where systems connect with each other. Aside from the syntax, the other one is semantics, and semantics refers to the meaning of the data. So I can show you a date, and we can agree on what format the date is, but we also have to agree on what that date represents. If we say product delivery date, do we mean the date that the consumer gets the products in hands, or do we mean the date that we have given it to the delivery company, for example? If we say the inventory levels and the forecasted inventory levels, which forecast do we mean? Tomorrow, a week from now, and so on. So aside from syntax for systems, to make sure that the data can be moved between the systems, it is also important that you agree on the semantics. What does that date represent? If you would send me a list of dates of deliveries, are you sure that I understand the delivery date the same way that you do? And a computer system will not always be able to help you with that. So that challenge, both for syntax and semantics, if you want systems to be able to work together, is standards. And if you ever have transitioned from phones, you probably have tons of cables at home, from micro USB, USB-C, Apple adapters, and you can see how hard it is to agree on a standard, even if we're talking about the same functionality about charging your phone. So standards is really key if you want to work together in a supply chain. There are some common public standards, but the important thing is that both syntactics and semantically within the supply chain, you have to agree. And once that's possible, once you make that agreement, a lot of things are possible. And I'll show you on the next slide what is possible if you agree on the syntactic semantics and you have a good alignment of your processes and understanding, and then how technology can enable you to not only be more efficient but also more effective. So take a look at this.
Hello everyone, I'm a sorting robot. I know I look cute, but my skills are a lot more impressive. I can identify the information on each of the parcels effectively and sort them out precisely. My friends and I can process as many as 18,000 parcels in an hour.
This is a 1.3 square kilometer transit warehouse. The use of sorting robots improves efficiency, accuracy, and security during the sorting process, and also reduces manual labor costs by an astonishing 70%. This AI and logistics model is now revolutionizing the express delivery industry across the country. Between 2012 and 2016, online retail sales in China skyrocketed from 1.3 trillion to 5.2 trillion yuan, making the country the world's largest online retailer. With a flourishing development of online shopping, the express business is also booming. There are now around 8,000 express delivery companies in China and more than 2 million people working in the logistics industry. Last year, more than 31.28 billion parcels were delivered in the country, accounting for 40% of the world's total. Revenue from the express business has reached 400 billion yuan, while the per capita usage in China was approximately 23 deliveries per year. With the recent rise of AI and big data, the concept of smart logistics has been put into service. Drones and unmanned vehicles are delivering items faster than ever before as China's logistics sector prepares to enter the smart era.
So what you see in this video is that the rapid expansion of online and e-commerce in China has pushed companies to think about how they can more effectively manage the supply chain. And what is interesting that in China there is a lot of delivery companies. We've talked about this in the mobile commerce and e-commerce thing, and you will see that as these companies are delivering more packages, they're also looking at how can we do this more efficiently, more effectively. And and using technologies such as you saw in this video, RFID, to understand what the parcels are, using AI and robot technology to sort the packages and even deliver them. You can imagine that now with all this technology, it's becoming increasingly easier to monitor the performance of the supply chain, see where problems are, and identify where improvements could be made. So that shows you that even in something as physical as the package delivery, information plays a vital role. Thank you.